Hello everyone, welcome back to my channel. I am Nitya from Sri Venkateswara College of Engineering, Bangalore. Concept related to one of the subjects called mathematics. Now let us have a look towards the topics which we're gonna discuss in this video. That is triple integration and center of gravity. Volume of triple integration. As the name implies, triple integrals are three successive integrations used to calculate volume or to integrate in a fourth dimension over three other independent dimensions. Now let us know about the meaning of triple integration briefly. Just as a single integral over a curve represents an area that is two-dimension and a double integral over a curve represents a volume that is three-dimension, a triple integral represents a summation in a hypothetical fourth dimension. To understand this, imagine a slightly different scenario where the first three dimensions are space and time, and the fourth dimension is the third space dimension. Suppose you have an integral of z where z is a function of x, y and t, and x and y are also functions of t. Integrating z with respect to x and y gives us the volume of function of t. If we plug in a value for t, this gives us the numerical volume at a particular instance of time. Here are some of the rules which we have to follow during finding the volume of triple integration. That is, in general, if you are evaluating a triple integral of f of x, y, z over a volume V, by properly choosing the limits, you can integrate with respect to the three variables in any order. For example, if V represents a rectangular box, then for x, y and z, the limits of integration will be constants and the order does not matter at all. That is triple integration from E to F, C to D, A to B, F of dz, dy, dx equals to triple integration from C to D, A to B, E to F, F of dx, dz, dy, and so on for six different possible orders of integration. Now let's we move on to the concept called center of gravity. Center of gravity. The force of gravity on each little bit of an object is gmi, where g is the local gravitational constant and mi is the mass of the bit. For objects that are small compared to the radius of the earth, a reasonable assumption for all but a few special engineering calculations. The gravity constant is indeed constant from one point on object to another. Center of gravity locates the resultant weight of a system of particles. Consider system of n particles fixed within a region of space. The weights of particles can be replaced by a single resultant weight having defined point G of application. Resultant weight equals to total weight of n particles, that is WR equals to sigma of W. Sum of moments of weights of all the particles about x, y and z axis equals to moment of resultant weight about these axes. Summing moments about the x-axis. X bar WR equals to x1 bar W1 plus x2 bar W2 plus so on xn bar Wn. Summing moments about y-axis. Y bar WR equals to y1 bar W1 plus y2 bar W2 plus yn bar Wn. Although the weights do not produce a moment about z-axis, by rotating the coordinate system over 90° about x or y-axis with the particles fixed in it and summing moments about the y-axis. Z bar WR equals to Z1 bar W1 plus Z2 bar W2 plus Zn. Generally, x bar equals to sigma of x bar m over sigma of m, y bar equals to sigma of y bar m over sigma of m, z bar equals to sigma of z bar over sigma of m. And yeah, this is all about the brief explanation regarding the triple integration and center of gravity. And thank you all for watching my video.